Hi everyone. So today we will be discussing about DHCP. DHCP stands for Dynamic Host Configuration Protocol. DHCP begins with a DHCP discovery message. So this is what happens when you plug a computer into your Ethernet port into the back of the router. um, Given that that computer you just plug into the back of the router is not set to static IP address configuration. So assuming that it's on obtain IP address automatically configuration or DHCP, what it does is it will send a DHCP discovery message to the network. That message is a broadcast message because your DHCP client, in this example, it is a computer, doesn't know who the DHCP server yet. The message, the discovery message, would say or would be asking who the DHCP server is and that it needs an IP address. So it sends out the message to the network. And since this is a broadcast message, all devices connected to the network will receive the discovery message. When it gets to another device in the network that is not the DHCP server, the device will open the message, and when it sees that it is a discovery message, what it does is it discards the message because this um, device, for example, is not a DHCP server. But eventually, when that broadcast message gets to the DHCP server, in this example, it is a router. The router will open the message, and once it opens the message, it understands that it is a DHCP discovery message. Since this is a DHCP server, what it will do is it will look up for an available IP address in its IP address pool, and it will sends out a response going to the device who requested it. That response is what we call DHCP offer message. The DHCP offer message contains the IP address that the DHCP would want to offer to the DHCP client. Now, if you are wondering if the response or the DHCP offer message is going to be a broadcast, that actually depends. That depends on the DHCP discovery message flag that was set by the DHCP client. So when this DHCP client sends out the discovery message, it actually includes a discovery message flag. When the discovery message flag is set to 1, that means the DHCP server will respond via broadcast message. When it was set to 0, the DHCP uh, offer message is going to be a unicast. So let's just say that the DHCP discovery message flag was set by the client to 1. So this DHCP offer message is going to be a broadcast. It That means other devices in the network will get the DHCP offer message. When this computer, for example, receives that message, it opens up the message and it will find out that it is an IP address offer. And since it already has an IP address, it will simply discard the message until one of those broadcasters messages gets to the device who requested for an IP address. So this DHCP client will open the message and it will see the IP address that the DHCP is offering. The DHCP client will then respond to the DHCP server via broadcast message again um, that it would want to get that IP address. So that response is what we call DHCP request. So it sends out to the network as a broadcast message. And when it gets to the DHCP server, the DHCP server will give out that IP address to the DHCP client, and that is now what we call DHCP acknowledge message. So simply, DHCP acknowledge message tells your DHCP client that it will have that IP address. So in this example, the IP address given by the DHCP server is 192.168.1.6 with a subnet mask of 255.255.255.0. Now, you might be wondering what these numbers are doing here. So as we have learned during our OSI lesson or discussion, these numbers are what we call port numbers. These are specifically UDP ports. When the DHCP client sends out the discover message, it gets encapsulated in the transport layer. That means sequence number, port numbers are added to the actual data. So this message, when it comes from the DHCP client, it is going to be sent out. Okay, so the source port is going to be port 68, and the destination port it is going to be port 67. So it comes out from port 68 of the client, and it goes to the port 67 of the server. The ear here tells you that this server's port 67 is the listening port. So it listens for any DHCP discover message on port 67. Any response from the server comes out from port 67 and it goes to port 68 of the client. So port 68 of the client in this example is going to be the listening port because it listens out for a response from the DHCP server. So if we look up the segment, okay, that means the actual data, the actual DHCP offer message plus the header, you would see that the source port is 67 and the destination port is 68. So for you to easily remember how DHCP works, you can think of Dora. Okay, so again, just a recap, DHCP begins with a DHCP discover message. Okay, of course that will come from the DHCP client. Your DHCP server will look up for an IP address from its pool of IP addresses and then sends that out to whoever requested it in the network. That is what we call DHCP offer message. Okay, that's step 2 of the process. Step 3, DHCP request. That is when the DHCP client requests to get the IP address that was offered to it by the DHCP server. And the fourth one is what we call the DHCP acknowledge message. That is when the DHCP server uh, allows the DHCP client to lease that IP address. So that's it for today. If you have questions, feel free to email me. It's my email address is jomel.yap@concentrix.com. That's JOMEL.YAP@concentrix.com. Thank you.